Thanks, Carl, for that introduction, and it's great to have an opportunity to share some thoughts with people here today. I've enjoyed my role in Angus Australia now for about 6 years, and it's been a real pleasure working with such an outstanding team of people, some of which you've been hearing from this morning. But probably more importantly is the ability to be able to work at what I believe is a cutting edge of genetic improvement. That's, I guess, where my main passion is, and it's great to be able to be working with a group of cattle producers that internationally is doing an outstanding job, and that's what I want to share with you a little bit today. Is some analysis that I've recently done to try and quantify how well Angus breeds in Australia are doing on a global basis compared to maybe some of our competitors and other benchmarks. So that's the objective is just how does our genetic trend compare globally with others? To try and quantify then what the economic value of that has been to the Australian beef industry, and to make some assessment as to whether or not our pipeline that we're using for genetic improvement, using Angus as an example, has been effective. Because we've always got to question whether the way we're doing things is the best way, and whether there are improvements. And there's always improvements we can make. So I guess at the end of the day, the key role here is to identify, well, what can we do better to make better progress in the future. So looking at the first one, first objective, how do our genetic trends compare with other Angus populations globally? Of course, other countries like the US, Canada, New Zealand, UK run genetic evaluation systems. They publish estimated breeding values or EPDs in some countries, expected progeny differences. For traits, some traits are similar to ours, some are slightly different, some are very different. So it's quite a challenge, I suppose, to work out, well, on what basis can you make valid comparisons between countries. So there's a few things that need to be done. So just going through what we've done, I've chosen some example traits. So ideally, you might make these comparisons based on index values or dollars. I've found that's quite difficult. That's what I guess ultimately an objective might be. But initially, I've just looked at 3 traits: birth weight, 400-day weight, 4 traits actually, eye muscle area and marbling. So they're all traits that we can look at similar measures in other countries. They might be named differently, they might be defined slightly differently, but they're 4 example traits and all of obvious economic importance across countries. And I've been able to compare them, as I said, with genetic trends for those traits or similar traits in USA, Canada, New Zealand and UK. 2 of those countries, USA and Canada, use different genetic evaluation systems to what we do in Australia. They have their own in-house systems. New Zealand and UK both use breed plans, so there's obviously some greater parallels with those countries that use breed plan in terms of the traits we compare with. I've also attempted, this is a bit of a work in progress, but I'm also attempting to make some comparisons with other industries where it makes sense to do so. And I'm still working with some colleagues to try and get some relevant comparative data for other industries, but I've certainly got some from Holsteins, and we're often told that the dairy industry does a very good job at genetic improvement, so I thought, well, looking at the trends achieved Holsteins might be quite interesting. Obviously not those 4 traits, but comparing our trends with Holsteins for traits of relevance to the dairy industry might be useful. The other thing I need to do is to somehow try and standardise those trends across countries. So, for example, many of you would know that in the US and Canada they don't use EBVs, they use EPDs. And EPDs is essentially half an EBV. It's the expected progeny differences of sire between sires rather than the actual estimates of the genetic merit of the individual sire. So that's a pretty easy calculation. We just need to double the EPDs to make them comparable with EBVs. The more difficult thing is the next bit is that the different traits that are measured and evaluated in different countries have different amounts of variation, genetic variation around them, partly because of the way those traits have been measured and defined, and partly because of the environments that they've been measured in, for example. So I need to make some adjustments there. Now I'm going to attempt to show you how I've done that. If we just take, for example, birth weight, these are the adjusted birth weights. They're basically raw birth weights. They've been adjusted for the age of dam effects, so a little there's this statistic that measures the variation. It's called standard deviation. It's a statistical term, and the standard deviation for that population is 5.1 kilos. Now, if you look at that, it's typically called by biologists the bell-shaped curve. Many of the traits that we record have got that characteristic where most of the measurements are around the middle and a few are to the extremes. And the standard deviation is a way of quantifying that variation. What I've done there is I've shown you those bands there show that the variation from one standard deviation either side of the mean, and that accounts for roughly 68% of the population, so about two-thirds, a bit more than two-thirds of the population. Two standard deviations either side account for a further 24% of the population, so about 94%. And then three standard deviations account for about all of the population, in fact about 98% of the population. So sometimes you might hear a statistician talk about, or you might hear Carl Tesling talk about an animal, well, his EBV is three standard deviations away from the mean, so he's an outlier extreme animal. It means that animal's is right on the extremes. And we see that those, if you look at those birth weights, three standard deviations either side of the population certainly account for that whole population. Now, similarly, if you look at the EBVs for those 56,000 calves, the average estimated breeding value for those was 4.4 kilos. And there's also a standard deviation around that EBV, that's 1.5 kilos. So if we put those bands in 1.5 kilo lots, that shows you that we can quantify those differences in EBVs in standard deviation units, in fact genetic standard deviation units, because this is a measure, estimated breeding values are a measure of genetic differences. So what I've done is I've effectively done that, converted the birth weight EBV trends for Australia and for the other countries according to their genetic standard deviation. So we're then, rather than comparing animals on actual units, for example in the US their birth weights might be in pounds, for example, but by putting them into standard deviation units we can then make them more comparable anyway, make any comparisons a bit more relevant. So what I've done here then for birth weight is I've got Australia is the line in red, and the other four lines relate to the other three countries, USA, Canada, UK and New Zealand. For the purpose of this talk, I haven't identified which of the other countries are, because I know we've got a Kiwi in the audience, and he may not be impressed if I show that New Zealand's not doing as well as the rest of the world, etc. It's not really relevant to the discussion what the other countries are. All I wanted to show you is how Australia is comparing to these other four countries. Australia is the red line, so this is birth weight. So the objective for most people is not to increase birth weight too much, because that's related obviously to calving particularly. So in Australia we've increased birth weight a bit, but certainly we've plateaued off since about 2007. One of the countries, the birth weight has increased, birth weight has continued to increase, and for these three countries here they've done a good job of having birth weight declining. Now, two of these countries here don't use breed plan, so their birth weight trends are not affected. So they're individual, and in those countries, the birth weight genetic evaluation doesn't take into account genetic trends in related weights. So they use a single trait analysis for birth weight. And some would argue, including myself, that their birth weight trends are probably unrealistically low because they're not taking into account the fact that correlations with later weights, in fact, will pull up birth weight. So these may not be quite as impressive. Two of these, at least, as what they appear in my mind. One of them is very impressive because it is part of the breed plan multi-trait analysis, and in fact, it is New Zealand. So New Zealand is doing very well for reducing their birth weight trend relative to Australia. Australia's not doing too bad. And you would argue, well, why is New Zealand doing better? And it's a good question, but maybe in New Zealand, because a lot of Angus bulls are used in dairy herds, that reduced birth weight is actually a very important selection objective. So we've got Angus breeders in New Zealand putting a particular attention on keeping birth weight low, and they've done a very good job at it. The other two countries are the North American ones. So that's Australia. Birth weight, I'd say we're not going too bad there, really. If we look now then at another trait, yearling weight. Again, Australia's the red line, the other lines of the other countries. So our genetic trend, and I should have explained previously, that these are in genetic standard deviation units, so they're roughly comparable, taking into account the differences in the definition of 400-day weight versus yearling weight, kilos versus pounds, EBVs versus EPDs, etc., and scale them according to the different variation in those countries. So for yearling weight, for growth, Australia is certainly very competitive with those other countries in terms of the genetic progress we've made. Now, we look at that, just also bear in mind that at least one of those countries, North America, has got a much bigger cattle population that they're selecting from than Australia. Their opportunity for genetic progress, hence, is much greater. So I would have argued that based on the size of the Australian breeding population, by using genetic selection, our breeders have done very well. This has nothing to do with Angus Australia. This is what our breeders have achieved. You and your fellow breeders have achieved through genetic trend. If we look at another trait, Australia. It's age, endpoint, L-scan VMAs versus ribeye area, which some of the other countries use ribeye area to scale them according to their genetic standard deviations. Again, we see the genetic trend in standard deviation units achieved by Australia is very good compared to those other countries. And the last one I looked at is scan IMF or marble score, depending on which country, how they express. Some countries express their marbling EBVs, EPDs, if you like, in marble score units where you're in intramuscular fat, but by the scaling procedure I've used, we can make them pretty well comparable, and again you can see that Australia is for marbling has done pretty well. Now again, we need to take into account that how has Australia achieved our genetic improvement? Well, we've done that through use of breed plan, through genetic selection. We've also done it through using the global gene pool. So many Australian breeders, particularly in the Angus breed, have done a very good job at selecting the best genetics in the world for a trait like marbling, for example. And marbling has been an important selection criterion for Angus globally, and that can be seen there for those genetic trends. All of those four countries have achieved positive trend for intramuscular fat or marbling, which is very pleasing for the breed, because we source genetics globally, and particularly from some of these very big populations like the USA and Canada, North America, New Zealand, we can continue to make very good progress. So not going too bad when we look at those trait by trait comparisons. So how do we go compared to the Holsteins? You reckon it's going to make us look pretty sad? I thought it would. I'm always told that the Holsteins, they know what they're doing. They put a lot of focus on genetic improvement. They'll leave us hands down. I only got this data very recently, but the red lines there are for Angus trends for 3 traits, 400-day weight, Australia, intramuscular fat, and the blue ones are 3 traits in the dairy industry that they select for: milk yield, protein content, and fat content in milk. And they're the 3 bars at the bottom. So for those 3 example traits, their genetic progress, in fact, when we standardise it, is not as great as what it's been in the Angus population in Australia for those 3 traits. So, as I said, this is a bit of a work in progress. I'm working with some colleagues, people like Rob Banks, who's in the room, and a couple of other geneticists to try and get some other comparative data for other species, for other populations. And again, the purpose of it is just to really enable us to be able to benchmark. It's not really to show how well we're doing, really, but to benchmark and see whether, in fact, it's as satisfactory as the improvement we're making. And I guess today that's looking reasonably good. So another objective of this exercise then was to make an attempt of quantifying then what impact has that had on the value of beef production in the commercial sector in Australia. So there's a few factors we need to take into account. Then do a model. I worked with some economists once and they said we can model anything because it's all about the assumptions you throw into the model. And in any model you can actually come up with the answer that you like. So I'm not sure whether that's making you sceptical about the result, but I'll show it to you anyway. So if we look at the realised genetic trend in Angus herds up to today, or up to the end of last year, for example, and the objective was to estimate, well, what has that impact been on the value of commercial beef production in Australia? I've ignored in this the benefits that might have accrued in the subtropical northern Southern Australia, because I've really only attempted to do this for the temperate part of Australia where most Angus are used, but we do know that these days Angus are increasingly used in the north, in the subtropics. And I've also ignored really the value that's achieving in the seed stock herds themselves and focus on the gains in commercial herds that are customers of our bull breeding herds. So that's the realised trend in the Angus breeding index that Andrew just spoke about a while ago for Angus over time. And we'll see that in the last few years we've been making averaging about $2.68 per year improvement. It's not as fast now as what it was back in the early days of when we had some outstanding size helpers make greater rates of genetic progress for these traits in the index. But it's been a pretty linear trend really. We're continuing to make that genetic progress. So what does that $2.68 per year mean then when we extrapolate that across the commercial beef industry? So to do that, one of the things I need to do is come up with an estimate of, well, what proportion of the bulls that are out, they're used in the commercial, in the temperate beef industry in Australia are actually Angus versus other breeds. And no one collects statistics on that. But what we can do is use the statistics that are published by ARCBA, the Australian Registered Cattle Breeders Association, that publish each year the registration statistics for all the main breeds, including Angus and the other breeds that are used in temperate Australia. So back in about 1990, Angus had about a 10 to 12% share of that registrations for temperate breeds. That would include other British breeds, it would include Euro breeds that are used in temperate Australia, but it doesn't include the tropical breeds, for example. And that's increased today to about 47%, close to 50%. So close to 50% of the registered cattle in the temperate breeds in Australia today are Angus. So that's been quite a big shift in terms of the proportion of Angus used or the influence of Angus over time. Now that's not necessarily totally reflective of the composition of the cow herd, but it's the best I can come up with at the moment, and it's probably roughly proportional, I would argue. The other bit of information I need for my little model is, well, how many cows we've got out there. MLA publish this information occasionally. I got this information from Ben Thomas, one of the MLA head office consultants, who was able to provide with those sort of statistics. And again, I've made an assumption that about half of those cows in Australia reside in temperate regions or subtropical regions that are still reasonably temperate, where Angus bulls are commonly used. So if you look at Australia, that's basically below that line. So it's in southern Queensland, and that's a few years old now, that graphic, but it does roughly show you where the distribution of cattle are in Australia. So about half of them are below the line in what we call southern Australia, or half above the line. So I've only really estimated these values for the animals below the line. And over time, then, based on the MLA's statistics, there's about 6.72 million cows in that population up to 2014. And then I apply the ARCBA proportions, that equates to about 316 million of those cows join to Angus bulls. So that's how I've estimated how many cows out there that are exposed to Angus bulls. And I've actually done the model to extrapolate the returns beyond 2014, and I've assumed there's no change in that population. Obviously, it may go up. It probably will go up given prices. The population probably will go up a little bit in the next few years, but haven't used a crystal ball. I've ignored that factor. So basically, Angus cows are joined to a bit over 3 million. Angus bulls are joined, I'd estimate, for around about 3 million cows per year. Okay, the other bit of assumption, lots of assumptions in the model, isn't there? The other assumption you've got to make is, well, how many of those commercial cows are joined to registered Angus bulls that come out of seed stock herds versus those that might be homebred bulls, for example. Angus bulls that might be homebred. So I've assumed that, and this is something where you as breeders might be able to help me a bit, but I've assumed that about 3/4 of the Angus bulls out there that are used in commercial herds come out of seed stock herds or out of bull breeding herds. Maybe it's too high, maybe it's too low, I don't know. But and a couple of other people have done similar modelling and used similar things. So I've assumed that about 3/4 of the cows out there are joined, that are joined to Angus bulls, are joined to registered bulls, reported bulls. those bulls then I've assumed that their genetic improvement is happening a generation behind the genetic improvement in the seed stock herd. I'll show you that in a moment. Just for completeness, the other 25%, I've assumed that I call those Tier 2 commercial herds, and they've got a 2-generation lag behind it. When we've modelled this sort of thing in the past, typically we find that if you're a commercial herd and you consistently buy bulls from an average bull from a bull breeding herd, well, your rate of genetic progress will be exactly the same rate as that bull breeding herd because you're buying an average bull every year, but it'll be about 5 years behind because obviously your genetics is there, the genetics that was in that herd maybe 5 years ago. So it'll increase at the same rate, but there'll be a generation lag. So I assume a 5-year lag for those herds which I call Tier 1 herds, that buy bulls from registered herds, and a 10-year lag, but at the same rate for other herds that might breed their own bulls, for example. Then when I plot that out, what it looks like is that the dark line there is the genetic progress in the seed stock herds. This line here is the genetic progress in Tier 1 commercial herds that buy their bulls from seed stock herds, and this line here is screen slating, but the other line is the genetic trend in what I call the Tier 2 herds that might be breeding their own bulls, but they're still making genetic progress because they're tagging on behind the rest of the industry. Okay, so that's what the genetic gain looks like. So now, in terms of putting an economic value on this, I need to take into account that $1 made 20 years ago is different to $1 made today, which is different to $1 made in 10 years' time. So I've got to actually discount, that's what economists typically do, they discount economic returns over time and put them in present-day values. So I've done that, and I've also assumed that after 2014 there's been no further increase in the cattle population, so no further increase in the share of Angus in that population, and no further genetic trend. So all I'm really doing is quantifying the gains that have been made up to this point today, but taking into account that will have a flow-on effect over the next 10 years in those Tier 1 and Tier 2 commercial herds. So this is what it looks like, the value of the annual, let's say annual lag gravity, that's what is the annual value of the gains per year across the industry. So at the moment, the value of gains is bit over $100 billion per year in present, undiscounted, so that's in undiscounted terms. Then when I apply that discounting that an economist should do, again, it's the same because we're not discounting today's gains because we're putting the dollars into today's terms. The dollars that were made back here have been discounted quite a bit and gains made in the future come down because the dollar we make in 10 years' time obviously is going to be less than a dollar that's made today. So that's the income gains. It makes more sense than when we look at this graph here, which shows you what the cumulative gains are over time, then taking into account that add up all those gains over time and then also extrapolating into the next 10 years. So the gains made up to 2014, that equates to about $1.62 billion worth of genetic gain, economic gain, through genetic improvement. And then that'll have a flow-through effect over the next 10 years to add up to about $2.5 billion. So my little model would estimate that the value of that genetic improvement made by Angus breeders in Australia today is worth $1.62 billion, but the impact of that gain made today will continue into the next 10 years and will be valued at $2.5 billion in today's dollars. So that's some numbers around it for better or worse. Okay, now the last thing is that based on those bit of evidence I've given you, the question is, well, has the genetic improvement pipeline for Angus been effective? I would argue that yes, it's been very effective based on the fact that our rates of gain have been higher or at least equivalent to other major Angus populations, and certainly when we compare them with Australian dairy, it's quite revealing in terms of what we've been able to achieve. And the economic returns to the beef industry have been very substantial. We're talking about numbers there that people treasurers like to talk about in billions. So I think we could argue that yes, there has been some very substantial gains. Now, having done this, not everybody would argue that looking at genetic trends for indexes is necessarily going to explain what everyone's trying to do through genetic improvement. So this analysis certainly doesn't take into account, I've just looked at the Angus breeding index, as Andrew has indicated, is pretty descriptive of profitability for situations where Angus bulls are used. The best we can do so far using the breed object model. But of course, some breeds out there have got totally different breeding objectives to the breeding index. They might be trying to select for other things that I haven't been able to quantify here either. And when often I think when people argue, well, the genetic evaluation pipeline is not working for some breeds or some parts of Australia, I think it might be because possibly we're not actually quantifying very well what they're trying to achieve in their breeding programs. So that's obviously an issue, but at least by using trends in the profitability index, we're getting some, it's a good benchmark anyways for how we're progressing. So back to this trend here. So the real purpose of this is not to give ourselves a pat on the back, but it's really to sort of quantify how we're going. We're increasing that about $2.68 a year in our average Angus breeding index value, which is about 3.5% per year. If we calculate what we could potentially be increasing at, we could potentially be increasing at a much greater rate than that. If everyone was focused on that index, for example, and didn't have other breeding objectives, or if we had more efficient breeding programs or more efficient pipeline. So really, and the other interesting thing when we look at that graph is that the rate of progress we're making today is in fact, no better really than what it was certainly not as good as what we're making in the around 2000 mark, late 90s. But you would be able to tell me better than my guess as to why we've probably slowed down the rate of genetic progress a bit, because I think back in these days, there's quite a lot of concentration of genetics going on in the Angus breed, and we've learned from that through the impact of that on recessive genes, etc. We've learned that we've got to actually think more about genetic diversity as well as genetic progress, genetic gain. So that's another thing we need to take into account in trying to go faster in the future, is we've got to also take into account we need to maintain genetic diversity so that we don't increase the incidence of issues related to inbreeding, like recessive gene problems and other issues related to loss of diversity. So the real challenge is to work out how we can make faster rates of genetic progress at the same time as maintaining our genetic diversity and being able to make that a sustainable increase over time. I think the sobering thing to my mind is that if you look at what the MLA estimates as the decline in terms of trade for farmers, so this is not just beef producers, this is farmers, so it's a fairly gross figure. But there are estimates, in fact, friend Rob Bank shared this with me a couple of years ago, that the long-term trends are about a decline of about 2.5% per annum in terms of trade. So that's really the prices you receive for what you're producing versus your costs of production, and that's a long-term decline, and you as producers know that far better than I. But at least through genetic improvement alone, by people buying average Angus bulls over time, I'm not talking about the best Angus bulls, average Angus bulls, because these are average genetic trends. People are buying average Angus bulls to use in their herd over time are increasing their profitability based on this index at a rate greater than that loss in terms of trade. So hopefully that helps them go. Hopefully they're doing other things too as well to improve their productivity. But at least through genetic improvement, by using Angus bulls, they're at least ahead of the decline in terms of trade. So at least that's probably the benchmark in terms of we don't want to be going any worse than that, otherwise we're not helping the situation at all. So that's it from me. I'm very happy to answer questions. Thanks for putting up with my modelling exercise. I'm always interested in ideas from people how things could be done better, differently, other things we need to take into account. So thanks for coming.